Hello, welcome to another Data Science with Julia video. So, today we are going to look into a thing called K-means clustering. That is like this is unsupervised learning. If you look at learning till now, you would have looked like, okay, this is the iris data set, and this is setosa, versicolor, and virginica, and this is the petal sepal length, so classify it and all those stuff. So labels are being given with petal and sepal length, whether it's virginica, setosa, or versicolor. Or if you look at Titanic data set, okay, whether someone is male, female, his age, whether they have survived or not, their class, that is like what class they traveled, first class, second class, or whatever it is. All those it would have been given, and the label, whether they have survived or not, would have been given. But this k-means clustering, there is no need to give any labels. It is just used. You just put some data to it, and it will just group some data and give it to you. So let's say like in a shopping, like you don't know, you have a lot of data, and you don't know like how to segregate people and all those stuff. So you just give it to k-means clustering and say that okay, cluster the data into 10 groups, and it'll cluster it into 10 groups and give it to you. Then it's up to you to analyze each and every group and find out like, okay, this group behaves like this and that group behaves like that. Okay, so it's kind of unsupervised learning algorithm, and we'll see how it is. Like if you're only familiar with supervised learning, it might look like magic, but yeah, like once you have learned, everything is what to say, not a magic. Okay, so that's the thing, right? So let us see like how it is and all those stuff. So I think this is going to be a long video or something like that. So or like yeah, I'll try to break it into two videos. So I don't know like how long it's going to be. So yeah, so let's you have this two data points, like okay, like over here you have this okay, actually two clusters over here, but for us it's two clusters. For a computer it knows nothing, right? For it it's just like some 6 points or something like that. So imagine in 2D space there are just 6 points. Okay, so how to cluster them? So you intuitively know that this should be a cluster. That is the left side thing should be a cluster, and the right side thing should be another cluster. Okay, so but how computer knows? Okay, so the first thing what we do is, let me make this bigger. Okay, so the first thing what we do is we just take 2 points. Like we just take 2 points, and what is this? Okay, I don't know. Oh, okay, right. Okay, we just take 2 points and make one. We just mark it as one as the midpoint. So this is not a midpoint, but we just mark it. Okay, so saying that okay, it's a midpoint or a center or something like that. Okay, so that's the thing, and we also mark this one as midpoint. Any two random points. Okay, so that's the thing. Now what we do in the next stage is okay. So since this is the midpoint, okay, so since this is the midpoint, okay, let's say, okay, now we take each and every point, okay. This point is near to this one, so, okay, first we make the midpoint red, okay, so because the cross is red, okay, so we make the midpoint red, and then we check this one. This one is near this red thing, so this also becomes red, and this one is near the red thing, so this also becomes red. Similarly for blue, these two are near the blue compared to the red, so they become blue. Okay, so that's how it is. Okay, so next what we do is like now we recalculate midpoint for these two clusters. Okay, so uh, so I don't know why the zoom is really annoying. So we are recalculating the midpoint for this three dots. We recalculate midpoint, and it's going to be here. And next for these three dots, we are going to recalculate midpoint, and it's going to be here. So you see now it is clustered. So that's it. So and even if you do it n number of times, this will always be red and this will always be blue. Okay, because the midpoint is over here and it's going to stay put, and this blue midpoint is over here and it's going to stay put. Okay, so it's not going to move. So that's the clustering thing. Okay, so now let's take another situation where this is an interesting situation. So if you can zoom, we selected two random points, and this one is the red's first midpoint, and this one is the blue's first midpoint. So this becomes red and this becomes blue. But if you see, even this one is near to this one. So assume that okay, this is near to this one. Okay, so I don't know. I haven't measured the distance and all those stuff. So this one also becomes blue, and since all these are slightly near to blue compared to red. Okay, so all these things are slightly near to blue, these also become blue. So by selecting these two things at random, there is a lot of blue and it's not clustered properly. Okay, but this algorithm can cure itself. So like what happens is now we calculate the midpoint. Okay, so there is only one red midpoint. So red just stays put over there. The midpoint just stays put over there. So, but the blue's midpoint just moves away. Okay, because like look, yeah, these are all colored blue, but so the midpoint of this colored stuff will be somewhere over here, right? And this thing, this extreme blue will pull it slightly more over here to the right. So that's what happens. So the blue's midpoint just moves right. Okay, so now what happens is since red's midpoint is still this one, once again, if we recolor it, these two will become red. Okay, because this is more near to this one and this is more near to this one. Okay, compared to this one. Okay, so that's the thing. Okay, now we once again center it, and so now what happens? Like automatically the red midpoint goes to the center of the red cluster, and the blue midpoint goes to the center of the blue cluster. Okay, so very amazing, right? So how it works and all those stuff. Just midpoint recolor, midpoint recolor, midpoint recolor. That's it. Okay. So, and once nothing changes, you just exit. But in our program, we are not going to do like that. We are just going to do like, okay, we are just going to take the number of points, that is 6 points, and okay, like two clusters, that is the k value is 2. That's why it means k means clustering. K is the number of cluster values. Okay. So we are just going to take k is equal to 2. What is 6 by 2? We are going to do it for 2 iterations, I think. So that's how it is. So that's what we are going to do. And yeah, I've kept it as simple as possible. So let's go into the program. Okay, so yeah. Uh, let me. Okay, fine. Right. And okay, right. Okay. Let me just go into the program. Okay, so what we are doing. Okay, so we can think these points as vectors. Vectors means okay, this is imagine like this is horizontal is x and vertical is y. So all these points are vectors. So in vectors, imagine like okay, the first element is x and second element is y. Okay, so we are going to build our own vector library. Okay, so that's what we are just going to do. So yeah, in Julia, like okay, yeah, we just have these two vectors and all those stuff. Okay, I'll just do it in another video because like uh, no, okay, fine, I'll just do it in this video also, right? So I don't know why my mood keeps changing. Okay, so you just have two vectors a and b. Okay, so and we just put a plus b and 2 gets added element wise. So that's really good. Okay, because we want to find the midpoint. So that's what I'm just doing. And we can also do this thing like for n number of vectors, we can put something like plus and reduce. Okay, and you just give a, b, and it just gives the same. Okay, and we also have c, d, and I just put reduce and plus, and that's it. So that's how it is. And now what I'm just doing is like to find the midpoint, I'm just putting reduce plus and array of vectors. Okay, so and now midpoint is nothing but add all vectors and just find and just divide it by the number of vectors. That will just give you the midpoint. Okay, so it's simple geometry. So that's it. So otherwise Google like how to find midpoint of n number of points. Okay, so that's how it is. Now I'll just find midpoint of a comma b and I'm just getting something which seems right. Okay, so that's the thing. And yeah, I'm just doing for some more values like 0 comma 0 and 2 comma 2. It should be 1 comma 1. Yeah, seems right. Okay, so that's the thing. And okay, similarly, addition, subtraction also takes element wise. So you have this 0 0 and 3 4. So if I subtract, it becomes minus 3 and minus 4. Okay. So now I am just doing this different square. Okay, this different square I'm just doing, and it becomes 9 and 16. Okay, so this dot can means element wise power, and this means square. Okay, so that's it, right. So yeah, so that's how it is, and it becomes 9 and 16. So if I just do sum of squares, it becomes 25, and if I take square root of sum of squares, it becomes 5. So not we are just all what we are just doing. What we have done here is like we have just found the distance between the first vector and second vector. Okay, so imagine points 0 0 and 3 and 4. So actually they form, and if you just what to say, they kind of form a right angle triangle. So like 0 0, 3 4 and 0 3, they form a right angle triangle, and the hypotenuse length is what to say 5, and that's what we just formed. Actually that's what is the distance also, right? So so similarly we just quote this distance function, right? And okay, so we just do this one distance of 0 0 and 3 and 4, and what to say, we just get the distance formula. And similarly magnitude, what is magnitude? Magnitude is nothing but like what to say, like okay, you need to know about vectors. You can go to this one, like Khan Academy vectors. Okay, Khan Academy vectors, and learn about it. So I hope he has given in. Yeah, so this one. So yeah, possibly I'll give this link to you, right? So that's the thing. So why we are doing is like, okay, we can imagine points as vectors. Okay, so that's the thing, right? So yeah, uh, let me just close this one. So okay, so we are just finding distance. Okay, yeah, that seems good. And magnitude is nothing but like, okay, you just square, okay, all elements in a vector. Okay, so that's what we are just doing over here. You just sum it up, okay, and take the square root. Okay, that's the magnitude. Okay, and unit vector is nothing but a vector divided by its own magnitude, and that's the thing. So we just find magnitude of 3 and 4, and the magnitude should be 5. Okay, and 3 by 5 is zero point 0.6 and 4 by 5 is zero point 0.8. So we are just getting it. So if you don't know about vectors, yeah, please read about vectors. So we looked about k-means, and we also looked about vectors in this video. That is like we now have some kind of intuition about k-means clustering, and we looked about vectors. So possibly in the next video, we will what to say, start doing the clustering and all those stuff. Okay. So I will explain how we are doing this clustering. Okay. So that will be explained in next video. Okay. Anyway, thanks for watching. Uh, bye. Right. Okay, hello all, welcome to Data Science with Julia. Possibly, I think this video will be edited with another video, and you will see it as one, but I'm just making it as two videos. Like, okay, so in last video you saw like, yeah, about vectors. Okay, about you had intuition about k-means and vectors. Okay, so or how to process vectors with Julia. So what I've done is like, okay, this you've got this vector what to say functions I've developed. So I've just taken this thing and put it into a thing called veclib, and it's there in a directory. Okay, so that's how it is. And then what I just did is like, okay, there is a thing called, okay, I have put a notebook called k-means clustering. Okay, and in this I've included this veclib. Okay, so that's how. And now, yeah, like I have coded a function called nearest. So you just give like okay, let me just explain it to you. So you just, okay, look at this cell. Okay, uh so let me just run it. Kernel restart and run ourselves. Okay. 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 Let me. Okay. I just ran it. Okay. So, okay, there is a function called nearest. So you just pass 2 points to it. Okay, let's call it as midpoint. Okay, and you just pass a vector to it. It'll say, uh, it will find out whether the 6 comma 6 is more nearer to this 1 comma 1 or 5 comma 5. Naturally, it's going to be 5 comma 5. Okay, so it's given 5 comma 5, and it's also giving the distance, and it's giving the midpoint index. Midpoint index is 1 comma 1 has index 1 and 5 comma 5 has index 2, so it gives us index 2. So that's how it is. So it just gives it, but yeah, you can even confuse it, 5 comma 5 and 7 comma 7. So it just takes the last one. So that's the thing. 6 comma 6 is equidistance from 5 comma 5 and 7 comma 7. So that's how it is. And okay, so that's how this nearest function works. Okay, so we have another function called cluster. Okay, so what we do is like, okay, like we have this midpoints. Okay, so and like we can give midpoints like, okay, like 1 comma 1, 5 comma 5, 7 comma 7. Okay, let me just explain it. Okay, there are 2 points, midpoints. Okay, like 0 comma 0 and 100 comma 100. So we need to cluster all these points, like which points will go near 0 comma 0 and 100 comma 100. So that's what this function does. Okay, so cluster, right? So yeah, so it just first forms empty clusters, and for each and every vector you're passing, that is this vector you're just passing, it just computes the distance with each and every midpoint. Okay, 0 comma 0 is very near to 0 comma 0, so it goes in the first cluster. And this one, okay, possibly is 105. 105 is very near to 100 comma 100, so this one goes to second cluster. And 5 comma 5 is very near to 0 comma 0 compared to 100 comma 100, so it once again goes to the first cluster, and so on and so forth. So yeah, that's how it just builds this cluster. So that's what this function cluster is all about. So, and it returns this cluster. So you just give it and it returns the cluster, right? So now, okay, with this cluster we can find the midpoints of this one. Okay, the first one, 0 comma 0 and 5 comma 5. Okay, that will be the new midpoints. Okay, so that's the thing. And now we can find the midpoints of the second cluster, this one. Okay, right? And that'll be a new midpoint. So we need to iterate it for few times. Okay, that's what this k means. Okay, so what I'm just doing is like I'm just getting, okay, I just coded my k means function over here, right? So and I'm just going to iterate it for vector length, that is like number of elements in this vector of vectors. Okay, and by k is just 2. So if you give 6 points and give 2, then it'll be like it'll be iterating 3 times or something like that. So that's how it is, right? So yeah, so now I'm just and then I'm just going to do this cluster and midpoint thing again and again. So that's the thing. Okay, so apart from that, nothing else. So I'm just doing like k means clustering, and I'm just giving it, and I just get this answer. So that's how k means clustering works. Okay, so I don't know whether I've explained it fast or slow or something like that, but I hope you got the intuition right. Work with the program, tinker with the program, and what to say, like yeah, so I'll just try to explain it. Okay, like yeah, first you got the centers, you'll pick random k centers, so you'll pick 2 centers over here, right? So or midpoints, you can call whatever it is. So and clusters, you use the cluster what to say function, and you just do it. Cluster function is over here, so you just do it. Okay, so and so for the clusters you pass this center. Okay, you just pass this centers which you have picked it at random, and you just pass the vectors and you just do it. And now you have this new centers which is uh, assigned as empty array for each and every vector array that's been returned in cluster. Okay, cluster returns this vector array like this one, right? So now you calculate new midpoint and push it to the center. Okay, and you just iterate it again and again. So that's how it is. So you can do it for 2 and you can do it for 3, but yeah, sometimes my program gives an error because if the same center has been assigned twice, program gets confused. But yeah, I think it shows the point, like it gives, okay, like now we need to do it again. Okay, oh god, why it's giving error after error. 2, okay, let me give 3. Yeah, now it's working, right? So now, okay, what happens is like, yeah, like it just clustered like this one. Okay, so okay, so 0 comma 0 and all this stuff. Okay, look, I think the number of arrays should be far higher than the number of the k value. Okay, so only then my program works. Otherwise, like there might be many same center could appear twice or something like that, and that confuses my program. I didn't bother to get unique centers and all those stuff. Okay, so that's the thing. Okay, so yeah, so it works. Okay, it just works. Now it is clustered a little bit different. Okay, so but yeah, it kind of works. But the thing is, like, yeah, sometimes it gets confused and all those things. Okay. So yeah, that's how it is, and this is how k-means clustering works. Okay. Anyway, thanks for watching. I hope you enjoyed this video and got some kind of intuition. Though my algorithm might not be very accurate, but it's accurate enough. That's what I just feel. So yeah. So yeah. Anyway, thanks for watching. Let's see in another video. Bye.